Hey, good afternoon, everyone. My name is Tom Riley. I'm going to do a talk on SpecFlow. So I've stolen this name shamelessly from Robert, who did a talk this morning. It's a complete coincidence, but he got his talk in first. So his talk was on Catalan, so named Almost Codeless Automation using BDD. So I've got almost the perfect sort of opposite of that. SpecFlow, almost code full automation using BDD. So quick introduction. So this morning, Rob does a really good job of covering most of the terminology, and when I've timed this, I run very close to the limits, so not going to go into much detail on these, but just a quick recap. We've got behavior-driven development, or BDD. So for short, is an approach to software development meant to focus every discipline or process on developing based on desired behaviors. We have acceptance tests, so tests designed to use the application as the end user would to verify its fit for purpose. Gherkin syntax, so a style of writing in which behaviors are documented. So given, when, then. I will give a little example on this one. So say we had a scenario, registered user can log in. We'd have a given, which is setting up the environment. So the given in this case might be given the user is on the login page and entered valid email address and entered valid password. When, so the action to trigger the target of your sort of test assertions, which in this case would be when the user clicks on the login button. And then we've got the then, which is the actual assertion. So in this case, then the user is logged in and directed to a profile page, for example. We've got SpecFlow Cucumber, which are tools commonly used for automating acceptance tests. They just simply turn Gherkin syntax into code that can run, or map Gherkin syntax to code that can run. SpecFlow is sort of C# and Cucumber is for sort of Java. Then Selenium, which I'm sure everyone's heard of, by far the most common, if not only, sort of means nowadays to drive a browser from code. And with that very quick intro, we'll nip straight into some code. So the site that I'm going to be doing some very quick demo against is the default ASP.NET application. I've made no changes to it. I've just created a new application, and this is the login page for it. I think we're just going to do some very simple test that an unregistered user using valid information can't log in, and a very quick required validation check. The reason I'm not doing a positive test is because I've not set up anything in the background, so there's no database to store users in. Okay, so just to walk through what this could look like. So we've got a EcoCon 2022 solution here, which has the website in it. And then we've got another project, which is for our tests of type acceptance. Naming convention isn't overly important. It's just very handy for blobbing later on in pipelines. So if we look at this acceptance test project, right, the only additional stuff I've added here over and above a standard C# class library is the SpecFlow sort of package and Selenium and the driver. So, and all those come pretty much as one. When you create that, you get these, you get features and you get step definitions. There are hooks here, which I'll gloss over because I want to just get through the basics of how it's set up. All the hooks is doing is creating a new browser for each scenario. So it's nothing overly tasty in there. Right, so we've got our feature, which is login. Our first scenario, an unregistered user tries to log in, receives an error message. So here we are setting up the environment. We're setting up the test. So given the user is on the login page and the user enters the email address, this string here, and the user enters the password, this guy, when the user clicks on the login button, then the validation summary contains invalid login attempt. And then we've got our second scenario here. So user enters an invalid email address, receives a validation error message. So given the user on login page and user enters the email address, so this one is very much invalid. When the user clicks the login button, then the email field validation should be as such. So I'll just quickly run them just to demonstrate they're working. They're fairly quick, so we can't really see exactly what's going on there, but we'll step through it shortly. Right, so this is Gherkin syntax. And the thing that SpecFlow gives us, or Gherkin, if you use an Java, is a mapping from this syntax into a C# code that we can run. So if we go and look at, let's just go straight in. Right, so here's our step definition file. So as you can see, very similar to the talk this morning, because we've got a given with a string, and that is directly mapped from here. That's how they map together. So I could just jump straight to it. The given, the user's on the login page. Just add a few breakpoints so we can see it happening, because it fires through pretty quick. Probably do. Breakpoints, just snap these. Right, so we've landed on the page. Email address has been entered. Password has been entered. And then it clicks on the login button and then finishes. Okay, so that is obviously a very quick whistle-stop tour of how that is kind of held together. One thing I haven't mentioned, and that we will come on to this in a minute, is why this is a single line of code rather than multiple. So typically you would see some commands passed to the driver, maybe some selectors, other stuff going on. Because I'm using Page Object Model, that's all sort of abstracted away, but we'll get onto that a little later. Okay, it's going to make a few changes to these features now. Only small, but just to demonstrate how easy it can be to edit these things. So let's add a new scenario for the required fields. That's what I was going to do, wasn't it? Right, what I should have done in hindsight is had these ready to copy and paste in, because I'm very bad at spelling, not great at typing, and I'm not using my own keyboard. So let's see how this goes. So what do we want? User fix login without entering any data. That's not great. I'm not a BA. Okay, so given. Let's see, we've got autocomplete. This is one of the nice things about having like a full-fledged IDE. We've got given and what we want it to do. So we want the user to be on the login page. That is probably all we want to do setup-wise, because we don't want to fill anything out. So when the user clicks on the login button, then what then have we got? That was it. So email field validation should be something along the lines of email field is required, I would have thought. There we go, and we'll check the password field as well. The password field validation should be password field is required. Let's see if that runs. Oh, I'll need to build it first. I run that. I've guessed those correctly, it'll pass, which I haven't. That's what it said. So the expected value of email field is required, full stop. Or it should be the email field is required. Oh, I was so close. The email field is required. I'm guessing that's going to be the same. The password field is required. Let's try that once more. Okay, great. So we've added a new scenario. Now that was very quick. It didn't take very long to do. That was because there's been some prep in advance as far as the page object models go. But again, we'll cover that in a moment. So the other thing I was going to show here was how you can reduce duplication of scenarios. So for example, here we've got you enter invalid email address. So if you wanted to test many different types of invalid email address, you don't really want to be copying and pasting this scenario over and over again. So what SpecFlow supports is examples. So I can change this to be a parameter almost that you pass in. Let's call that email address. And then just below here, we can use examples and create a little table. So we'll set the column as the name of that parameter, and it'll look them up. So I can say, what did I have in there before? Email address. Well, that's definitely valid. What else? Email dot address. And I don't know, email.com. That is not an email address either. Now fine, if I come and run these, you'll notice this becomes expandable. Oh, behind all my windows. Let's wait for that to finish. So they did all pass, and we can see an entry for each of the options here, which makes it a lot cleaner and a lot quicker to maintain. Because if you'd copied that 4 times, not 3 times, if you'd copied that 3 times and you'd changed one of the step definitions or something, then you'd have to change every one of those scenarios. In this case, there's no duplication. You change everything in one place. Anyone who's worked on any type of front-end automation, end-to-end automation, will know that it can quickly get flaky, if that's the right word, because the smallest change to the front end can break all these tests. And most of the time, those changes to the front end aren't noticed until these tests are run, which often is quite late on in the process. The quicker you can pick stuff up, the cheaper it is to fix. So let's have a look at Page Object Model. Before I go into that code at all, the kind of point of Page Object Model is to separate the instructions and assertion side of automation from the implementation of the application. So in this case, the implementation of the application is the front end, the HTML, the markup, the DOM, if you want to get technical with it, and that allows our tests to be, well, our steps to contain single lines as such. So our page object model in this case represents the login page. So our interaction in the user enters a password. The interaction with the page via the page object model is just enter password. And if we jump to that method, see here's the usual Selenium code you would find. So driver dot find element and then send keys. The selector, this is another kind of deduplication practice, just clean coding practice, I suppose, is I've put all the different selectors for different elements on the page at the top, so they're very easy to find and modify. You will notice I've used dirty full XPaths. That's just for expediency. I know there's nicer ways to do it, but I didn't want to modify the application at all with any IDs, so I've just left them in there. One of the advantages of the page object model that you don't see here is that as applications tend to be fairly complicated, they're usually built up of reusable components, and each one of those would have its own model, and a page object model would be built up of many components. So a perfect example is a date picker. Date pickers are notoriously awkward to test and are usually on a lot of forms if you've got a forms heavy application website. So if the date picker was, or the calendar control was changed during development, the page object model component for the calendar would be modified. And because all the pages that use that calendar are just using that same page object model, you don't have to change it anywhere else. And depending on who's responsible for maintaining those, which I will immediately come on to, sometimes changes like that go completely unnoticed. So the most successful implementation of SpecFlow page object model I've worked with was where the developers were responsible for maintaining the page object models, not the testers. So the testers did the features and the steps, but the page object models were maintained by the developers. If a test failed because something had changed, that was a bug for a dev to fix. And because the tests are alongside the application, as we can see here, so in this case, that's the application I'm testing. The developers can run the test on their local machine, and you would, because if you know you've changed the markup, you just go and check the page object model, modify that, run the tests. Not only have you ran some pretty good regression on your dev machine, before pushing it any further, but we've also got those tests up to date ready for any other time they ran down this development pipeline. Well, that was it. Next, I was going to refactor this slightly. So this one here is overly verbose, this scenario. So an unregistered user tries to log in and receives an error message. So in this case, the actual email address and the password that are entered don't matter. That's not an important part of the test. Those could be anything. So we'll refactor that slightly. Let's change that. You know, we don't even need to say that on the page. Okay, so let's create a new given. Well, given the user tries to log in, create that step in steps. Okay. So here we can reuse Page Object Model. We can say, okay, the first thing we're going to do is, oh, actually, we do need to navigate to the page on there. Where's my mouse? I've gone one step too far. Okay, let's just get rid of these. The user tries to log in. Okay, so we don't need to call those as separate things. We can just chain them together. So we can say enter email address. It needs to be a valid one. Say valid, it needs to pass validation. And then we're going to enter a password as well. So that reads very nice. That's easily discoverable because of IntelliSense. So if I run that test now, okay, that test should, I hope, still work. Yes, it does. Hurrah. Okay, so the last thing I wanted to show was adding a new element to the page object model. Right, so let's add, where should I add this? It doesn't, let's put it in here. And the user fix, remember me. Let's create this step. So this step, we don't have anything in the page object model for. So what is this going to be? This is going to be, remember me, click. Let's create a method for that instruction in here. So this is the side that ideally the developers be responsible for. There's nothing stopping testers from doing this side of things. Oh geez, I really can't do more than one thing at a time. Tried to talk and I forgot what I'm doing. Remember me, click, that was it. Okay, so this is going to go driver dot. I'm going to find the element. Selector. Remember me selector doesn't exist yet. Let's go and get that. That is definitely not the selector for it. This is not the best way to get selectors. It is just the fastest way to get really bad selectors. But it serves purpose for this. Okay, so hopefully, unless I've got some names wrong. I did get something wrong. Oh, just capitalization, right. Okay, so now if I put a breakpoint on there, and what happened immediately after that? Remember me click, then it was click on the login button. So let's see what happens afterwards. Okay. Let's debug that so we can see what's happening. Okay, so it's just about to click remember me. Fingers crossed it does. It did. Hooray. So let that carry on to conclusion. Okay, so that was like very, very quick kind of hopefully trying to showcase in maybe overly simplistic scenarios where some of the power of sort of SpecFlow page object model sort of comes from and how you implement it. It scales very well for huge systems, and I've seen it scale as such. It does work. So let's go back to my prepared presentation for the final slide. Okay, so I'm not going to dig into these as I was planning to because I'm running out of time. Gherkin syntax is a great way to format acceptance tests. It's kind of industry standard. It's BDD, and it does work very well. So SpecFlow Cucumber make automating acceptance tests a lot more accessible. Yeah, so without a tool like that, you would have lots of boilerplate code, and it wouldn't be overly readable. So the page object model pattern simplifies the code by creating a clear separation of concerns and responsibilities. So the key part here is the whole line, the separation of concerns and responsibilities. So because you've got all your interactions with the actual application stored in a separate place from your tests, you've got an API there. And if the developers are responsible for maintaining that API, with any luck, there's minimal changes required to the actual test code. So you've got full access to C# or Java language features and industry standard, well-established IDEs like Rider, Visual Studio. That could be very powerful. So in the past, when I've worked as an automation test engineer, a performance test engineer, and some of the tools aren't great. They might give you vanilla JavaScript to use, which although you can do a lot with, it's not great. It's normally not in an overly powerful IDE, like plain text editor, maybe with autocomplete. But having like tools like Visual Studio and C# to use is a huge help. So it uses well-established test runners for easy integration into continuous integration and delivery pipelines. So this again, there's no complexity there. You can have, there's always a certain amount of configuration in wiring up third-party tools with CI pipelines. Some of them do it better than others. You don't really need to do any of that because this is just picked up by CI pipelines as unit tests, which are almost the most common of some practices in CI pipelines. And it's just the same. The only awkward bit comes with having an environment available for them to run the tests against. But if you've got test environments, I don't think anyone's going to be unawares of how to set up another for testing against. Automation code can be in the same repository as the application. And ideally your infrastructure code, as Owen showed in his previous talks on AWS CDK. If you can have everything to do with an application in a single place, that's hugely advantageous. The tests can be run by developers on their development environments. I did touch on that earlier, where they're a lot more likely to be maintained if you're able to run them from like the earliest parts of the process. Page object models are easy for developers to maintain as and when they make changes. Again, a developer makes a change to markup. They know they've made that change. As long as it's part of the process, they know then to go and update the page object model and run the tests. And application and test code versions kept in sync. This can be incredibly useful. So say you have feature A and B going, and they've both got changes to front end. So there's test code changes, the page object models have changed. So you get into they get into a release candidate, they get in testing, and there's a regression test has failed on one of them. And to save hold in the release back, you want to pull that code out. So commonly, if the tests are stored in a different repository or they're in a third-party tool, you've got the test as they've been modified for the feature that's been reverted. So you can't run a full test pack again against the release after pulling those changes out because the test will fail. You need to roll them back separately if the tool even allows you to do that. Finally, allows for the reuse of application code in complex scenarios. So a simple example of this is data access. So if your tests have to seed some data, instead of having to write your own data access code, you can use the repositories that are already there because you're in the same solution. That opens sort of endless possibilities then for the scope of these tests, which you would otherwise have to write a lot more code to achieve. With that, I think that was the last point.